All right, so in this one, we're going to talk about a high-level overview of what makes up a full-stack web application, specifically focusing on the Java language in the back end. So strap in, we're going to learn everything that we need to know about how to understand everything at a high level. So first off, we are going to start with the front end and the communications layer. Now let me just briefly talk about each of these and then we'll dive in. So the front end is where you would get your HTML, CSS, JavaScript. Very common. A lot of boot camps only focus on this one pillar in these, I call these the 5 pillars of full stack web application development. In order to just focus on the front end, you can do that as part of an entire career. There's just not as many openings for job openings and whatnot in the real world for front end. However, front end is a decent place to get started with learning how to code. Some people will say, hey, learn HTML, CSS, and JavaScript first. And there's no right or wrong answer in terms of what language you should learn first. But yeah, that's one popular angle, is to go into front end first. So that's what front end is all about. Then there's a communications layer, and this pillar, if you will, of the 5 pillars, 1, 2, 3, 4, 5, this pillar goes between front end and the server side, which is, in our case, the Java language. So this allows you to communicate from the front end, so HTML, CSS, JavaScript, can send messages all the way over to the world of Java, or the server side language. You can put Java in here, you can put C#, you can put C++, you can put Python, you can put Node.js. There's a bunch of different languages that all do the same thing. So these 5 pillars are they can be completely generic, right? You don't have to put Java in here. And that's why I said communications layer. There's a specific technology that we're using here for this communications layer, but this can apply to any web application that is full stack. So this communication layer allows messages to travel from the front end all the way to Java and back. So from front end of Java and back. And same over here, there's the Java and the database. The database can be whatever database you like. It could be a NoSQL or whatever, not only SQL database like a MongoDB. It can be a SQL, it could be an H2, it can be a Postgres, a SQL Server, it doesn't matter, right? This is any database. They all have a way to communicate between the server, the backend language, which is the Java language, or like I said, any other language, C#, Node, etc., etc. There's a way to communicate between that language and the database, and vice versa. So communicate from Java to database and database back to Java. There's another communications layer in between those two things, and it's another technology that we leverage. Okay? Having said that, front end is, like I said, HTML, CSS, JavaScript is a language. Communication layer number 1 here and the communication layer number 2 here and the Java language all share the same language. These all are Java, okay? Or if you're in another world, again, these could all be Node, or these could all be Python or whatever. So these are just technologies, or the communications layers are the frameworks, which is another word to say, hey, we use the language that we're familiar with, in this case, the Java language, but it allows us to take away a lot of the details, a lot of the code, the boilerplate, the stuff that you don't really want to be concerned about. It takes away all that complexity and gives you a way to easily communicate between one layer or one pillar and another. That's what these communication layers are all about. So these are the Java language, these 2 communication layers, and obviously the Java language. And then the database is whatever the database language is, right? It's probably mostly SQL, or it could be something like Mongo, which leverages like a JavaScript-esque flavor. So that's very, very high level. So let's dive into the front end and the first communications layer, okay? First of all, the communications layer that we use in the world of Java is called Spring Web. So when we think about that first communication layer, it's called Spring Web. And the front end sends messages to this communication layer, to Spring Web, via something called an HTTP request. So the way the web works is on HTTP, Hypertext Transfer Protocol. Doesn't matter that you can or cannot know that. It's just something that I remember for no apparent reason. Doesn't serve me in any way, shape, or form to know that HTTP stands for Hypertext Transfer Protocol. HTTP request and response. So a request is we're sending a message out. Response is we're receiving a message back. So it's like, hey, how are you? And the person responds with, I'm fine, thanks. That's the situation that we're going here. We send a message, we get a response. The way we send a message is there's a structure to it, right? Everything in code, everything in computer talk has to be meticulously defined. There are specifications. There are pages and pages and pages of specification documentations that outline exactly what an HTTP request is and what an HTTP response is. And you can bore yourself to death with all the details. But really what it boils down to is the request has a method. The popular ones are get or post. So you can say I have an HTTP get request or an HTTP post request. Okay, those are common terminologies that we use when talking in the language of front-end and requests. HTTP post, HTTP get. There are other types of methods, but let's not worry about those. And how they are made up, the structure of those requests, have a header and a body. So the header does some stuff about describing what this request is, and the body can be the data that we want to send from one place to another. So the body, for example, if you are logging into an application, you're typing in your username and password and you're saying go, that's an example of an HTTP post, because an HTTP post request has a body, and that body will contain the username and the password that was typed into those text boxes. Right? If you can imagine a website with two text boxes, right? Username, password, you type in your username, you type in your password. When you say go, that information is sent via the body of the request. And the header talks about what this request is, right? I don't want to get into the specifics, but it's about what this request is. And that gets sent to the communications layer, to Spring Web, okay? And eventually, at some point down the road, we're going to get a response back, but let's not worry about that right now. Let's only look at the top level, okay? So when we send the request from the front end to the Spring Web, the first communications layer, common errors that you might see here are 400, 401, 403, 404. Okay, these are probably codes. These are HTTP status codes that you've seen before. Very common is 404. That one is, hey, you requested a page that just doesn't exist. And another one is 400. 400 you'll see a lot when you are trying to send data to the server, like with a post, but the data that you're sending doesn't match up with what the server is expecting, right? So the server wants something in particular, and you are sending something that doesn't match. It wants apples, and you're sending it oranges. And it says, I don't know what to do with these oranges. These are not what I expected, so it gives a 400 error code back. And then if you're trying to if you're sending a request to a URL, I should have mentioned these are URLs that the request goes to URLs. You could potentially not have access, right? You could potentially be cut out and say, no, you don't have the appropriate access to see this page. It could be an admin page or something, and you're not an administrative user, so you don't get access to it. Or you're not a super user, or you're not even registered in the application, right? Maybe you're just not a user at all. You haven't created an account yet. So that's where you can get these unauthorized 401, 403 type error codes. All right, let's move on down the line. Now let's go. So we just talked about front end to communication layer. Now let's talk about the communication layer, Spring Web, and how it talks to the Java layer, or the server-side layer, which is the Java language. Okay? So how does that work? When the first message comes from the front end and hits the communication layer, it does all the stuff that I said it would do, but then the communication layer, Spring Web, on the other side of this equation, when it's talking to Java, translates that request into Java objects. So it takes the text format that the HTTP requests globally or universally are just text, right? It translates it from just plain old text into Java objects that the Java language can use and can understand. And that is extremely helpful because when you're working in the world of Java, you don't want to be parsing a bunch of like text. You don't want to be like working with just string data. You want to be working with actual fully qualified, or whatever the word is that I want to use here, full objects, real objects. That's what we want to use, where you can access stuff with dot properties. You can say this user.get username, user.get password, right? We want to be able to say the dot this or dot that to interact with these objects. That's what makes Java helpful. That's what object-oriented programming is all about, being able to have dot properties and accessing all that stuff. If it's just plain text, there's nothing useful that you can do there. You need to translate it from text into Java objects. And that's what Spring Web does for you automatically, which is lovely. Okay, super, super helpful. Common errors that again, we're just talking about the top layer here. We're not talking about the response yet. I'll get that as we come back. But common errors here are 500, right? You might see a 500 internal server error is typically the message that you see. And that is because something broke on the Java side, right? The request was able to come through from the front end, So Java was able to receive the request information properly, and it wanted apples and you gave it apples. Awesome. But then something else happened down the line. Someone slipped on an apple. I guess I should use bananas. Anyway, something goes bad on the side, on the Java side, right? That's a common error that you'll see. And there's a plethora of ways that things could go wrong there and how to fix those. I can't really say with any sort of specific example here, other than something went wrong on the server side. So that's what happens. We take text and we turn it into Java objects. That's the important step here, and 500 errors can happen. So then we go on to the next set, which is Java talking to the next communication layer. Okay, and this next communication layer is what connects Java to a database. In the world of Java, we have something called Spring Data. Okay, the communications layer, the second one, is called Spring Data. It doesn't have to be Spring Data, but that's a very commonly used one with the Java stack with respect to creating web apps. Spring is highly leveraged. Some people love it. Most people love it. Most organizations use it. But with anything on the internet that's popular, it's going to have haters too. Some people absolutely hate the world of Spring, but they tend to be a vocal minority. Okay, how does Java interact with this next communication layer, the Spring Data layer? The whole purpose of this layer is to be able to communicate with a database. So we're communicating by taking Java objects and turning them into something that a database can understand. So just like that first communications layer that we saw, if I go back in the slides, the first communication layer took text, translates the HTTP request, and turns it into objects. We took text, translated it into objects. We converted it into objects. With this communication layer, with Spring Data, we do the same thing, only we take a Java object and turn it into something that a database can understand. Okay, and the first step in that process is to be able to tell the layer what it is that you want to do. And when it comes to databases, typically what you want to do falls into one of four categories, which is abbreviated with CRUD. You'll hear that a lot, doing CRUD, which is creating, reading, updating, or deleting data. Okay, I should have put the word data after all of these. Create data, read data, update data, delete data. Data, data, data. That's all we typically do as programmers on a day-to-day basis. Data in, data out, data manipulation, data translation, formatting, data, right? That's what currently the world revolves around data, and that's what we do as programmers, and that's why this layer is an important one. So Java, or more importantly, using Java, tell this Spring Data what it is you want to do. Do you want to save the data? In other words, do you want to create new data or update existing data? Do you want to read it? Do you want to say, hey, give me the list of all the users in this database so that I can do something with the users? Maybe you want to print out a report of all the users, right? That's a read operation. So Java will tell this Spring Data, hey, find all of the users that exist in the database. So reading is find me this, find me that. Look up the user by an ID. So let's say you have a username, you have an email address. Give me this, based on this email address, give me all the information in the database related to this email address. That is a read operation. You can also create data, which is also known as inserting data, right? Or saving data. You can have a brand new person who's registering for your application for the first time. Hey, I'm brand new. I want to register and create my account. Here's my information. Here's my username, my password, my name, my birth date, the urine sample, all that stuff. And you are sending it to be saved, right? So that's creating data, right? So that's what this does. Java tells the communication layer, I want to do that. We call that invoking methods. But anyway, that's what it's doing here. Yeah, you invoke some sort of CRUD operation. You create, read, update, and delete. Okay? So that's what Java tells the communication layer to do. Well, then the communication layer, when it's talking to the database, right? Previously, the communication layer was interfacing with Java. Now it needs to interface with the database. How does it interface with the database? It runs SQL statements, right? And I'm using a SQL database in this example. But again, this could be a NoSQL database. Okay? Same concepts apply, right? How you interact with a NoSQL database is fundamentally the same as how you interact with a SQL database. A SQL database, you are running statements, SQL commands, whatever, based on the stuff that you get from the Java side, right? So if Java said, hey, I want you to save this object into the database, then it's going to create an insert statement. So that's what this is going to do, is to say, okay, Java wants me to save this Java object and put it into the database. It's going to translate the Java object into an insert statement. The insert statement is a SQL statement. It's SQL code, right? We're going from the world of Java code to the world of SQL code, which is just SQL statements or scripts. Another way to refer to this. So a save gets turned into an insert statement. An update, if you want to update data from a Java object, it just turns that Java object into an update statement, right? Which is one line of code. It's how the databases interact and understand. It's how databases function, is based off of SQL statements and scripts. Again, you can read data. So give me a bunch of rows, give me a bunch of data based on, look up all the users in this database. What users exist? Tell me all the users, give me all the rows of data. It's like an Excel spreadsheet of data, right? So that's what's happening here. It's going to execute those scripts on the database. That's what this Spring data layer will do. Actually run those scripts on the database, okay? Now, we've reached the end. This is the end of the road going along the top route that we were just going along, right? The top route is what we have been doing, but now we need to go backwards and go back through the bottom route. So now we go from the database. What does the database then do once the communication layer, the Spring data layer, has sent these commands to it, in these scripts? The database sends back rows of data. Think rows in an Excel spreadsheet. It just gives the plain text it's almost like how does it actually send? It gets sent in. Anyway, I don't want to get into the specifics of how it's sent because it gets complicated and it doesn't need to be. I don't want to make this video complicated, but imagine Excel spreadsheet rows of data. So rows of data from an Excel spreadsheet being sent in that format. Let's just say it's comma separated, right? Each column is comma separated. Each piece of data is comma separated, and it sends that back to the Spring data layer, right? Spring data will receive a bunch of comma separated text, right? But comma separated text is not a Java object. So we have to go backwards to this, right? Where the communications layer talks to Java. And that's what happens here is it translates those SQL rows, in other words, the Excel spreadsheet rows, and turns it back into Java objects, right? That's what these communication layers do. They take in text and turn it into Java objects, or takes the Java objects and turns it into text or what have you. So it's a translation. It translates from one language to another. So in this case, we're translating from SQL into Java. That's what the Spring data layer will do. Translates it into Java objects. So then Java's happy. Cool. Java has a bunch of Java objects. Wonderful. That represent each of these rows of data. So we have a Java object representation of what was in a SQL database. Cool, awesome. So now, what do? We need to take from the world of Java, we want to make our way back to the front end, right? Because if, let's say we're reading data from a database, with give me all the users, the first request could be give me all the users from the database. And it travels and says, okay, give me all the users from the database. Okay, in the world of Java, what do I need to do in order to give you all the data that exists in the database? So let's talk to the database via the communications layer. Communications layer says, hey, give me all the data from the database with respect to all the users. Okay, it says it sends that data over here in SQL format and a bunch of Excel spreadsheet of all the users. Okay, let it translate that bunch of users into Java talk. So then we have a list of, or a collection of Java objects that represent all the users that existed in the database. Now what? The Java layer has to then take all those Java objects and send it as an HTTP response. So it needs to translate the collection of Java objects that represents all the users in the database and give it to the Spring Web layer so that it could turn it into a bunch of text that, when we go here, the communications layer sending it back to the front end, translates the HTTP response back into a body, which is going to have a list in text format of all the users that we then display on the front end, right? Display, and the front end being an HTML page. So that goes from give me, where is it? give me all of the users in the database all the way to, okay, I got users, let me send them back to you, and that gets all the way translated back to the front end where you can then display the users on a browser, in a browser, right? That is at a high level what happens in each of the 5 pillars, the 5 layers, whatever you want to call it, of full stack web application development, specifically for the Java language. But the beauty here is it doesn't have to be Java. You could copy paste this exact thing with, like I said, Node. Node uses, for its communication layer here in step 2, it uses something called Express, right? So in Java, we use Spring Web. In the world of Node, we have Express. And in the world of Node with a database, I forget what it does with Mongo and whatnot. I forget what, there's some technology that it uses to talk to Mongo. And then with Python, I don't know Python too well, but there's like Django, and there's all these technologies that do the exact same thing. It's all about translating text into server-side code, so text into Python code, and then talking from Python code into a SQL code, right? And back and forth. That's what we do day in and day out with full stack web applications. Okay, Ruby on Rails, another example of how we do this, right? This can be copy pasted into pretty much any language, more or less. Okay, more or less most modern languages. So yeah, that is at a high level what a full stack application is made up of. And if you can understand all these things at a high level, everything else then just becomes details. Okay, I understand that my problem, I'm running into a 400 bad request. What does that mean? That's right, 400 bad request means that my front end is not able to talk to my communication layer. So it hasn't even gotten to the world of Java yet. Sort of. It has, but in terms of this diagram, a 400 error happens before we get to the true Java code. It's still Java code, but it's someone else's Java code. Something fails here. So that's okay. That's the whole apples and oranges thing, right? But if we get a 500 error, then it's okay. We were we have apples and we gave it apples, it expected apples. So now something else is going wrong, and so on and so forth. So these kinds of things are really powerful for debugging, for not only understanding at a high level, but being able to get work done faster. Because when you fully comprehend all of these steps in this process, from front end to database back to front end, the debugging process becomes much simpler, and you can communicate more effectively with your peers about what's going wrong here. Okay, it gives you a very, very wonderful tool to communicate to other programmers. Also allows you to communicate in interviews, right? Because if you can talk about every single one of these 5 layers, or 5 pillars, again, whatever you want to call them, if you can effectively communicate that you understand each of these steps and what happens at a high level, it's so valuable. Like as an interviewer myself, where I've interviewed hundreds of people for coding jobs, when the person understands each of these layers intimately and understands at a high level as well as at a specific level, right? At a lower level. When you're a senior level programmer, you should know this stuff at a low level. When you're a junior level programmer, high level is great. Low level is bonus, right? You want to get low level maybe with just one of these pillars with a Java language. You want to get real low level to understand how all of it works. But yeah, that's my positioning about why this is so important. Everything about programming revolves around what's in front of you right now. That's how important this is. Okay? So, having said that, now in the next video in this series, I'm going to take this high-level information that I just presented to you and show you exactly where it fits into the code that I've already written when I created that app in 5 minutes, right? I had a little presentation where I created a web app in 5 minutes. If you haven't seen it, there's got to be a way to go back. If you're on YouTube, go back into the playlist. Maybe I've created a playlist. You can go back, check it out. The first video in the series will have that. If you're somewhere else, there's got to be another way to go back and see one of these other videos, okay? And I created a presentation where I created a web app in 5 minutes. So I did that real fast, but this applies to that presentation, and I will now take this information and dig into, at a lower level, each of the steps about how I create an entire web app from scratch in 5 minutes, using what's in front of you here. Go ahead above me somewhere, I'll have a video listed where you can click to go to the next one if you're on YouTube. If you're not, I'm sure there's a way to click and go to the next video. So I'll see you there.